R3 objectives 1, 2, and 3. We'll cover them all today. So we're talking about radicals, nth roots, radicals, and these are things that we've done before. And I'm going to put something up here from your book that you can take a picture of, and this is on page 27 in your book if you would prefer to screenshot. So I'll let you get that situated, and then we'll go from there. So let's talk about what's going on here. First off, this is what we're focused on. This is called the nth root of a. This little n is the index, and over here, n has to be greater than 1. We can't have negative numbers up here. They have to be integers, so no fractions, no decimals are allowed here. This index always has to be a positive. It says positive integer, but it really should just say a whole number greater than 1, okay? And the answer to the nth root of a is b. Now, there's a couple things that you have to keep in mind. We know the answer because b to the n will equal a, whatever that is. B to the n will equal what's underneath here. Okay, this is called the radicand. What's underneath the radical is called the radicand. This little number is the index. There's one specific condition that has to be met in one situation where we have to qualify it. If the index is even, okay, the index is even, both the radicand and the actual answer must be 0 or bigger. They have to be greater than or equal to 0. Meaning, if this is even and this is negative, then we're going to have a not real solution. Okay, and actually, in many cases, there will be no solution at all. But that's the one qualifier. That's the one exception. If the index is even, this has to be positive, and this has to be positive, or 0. All right, so let's keep that in mind. So we're just going to jump right in and do some problems. These are probably close to page 27 if they're not 27 in your book. But if you want to take a picture too, go ahead and get those in there, and then I want you to try to figure them out. Try to solve those. As you go through these, keep an eye out for negative radicands. Okay, so like here we have a negative, here we have a negative underneath the radical. And make a decision, is that going to be acceptable? Are we allowed to have a negative in that particular case? And if we are, then you can go ahead and evaluate it and simplify it. But if you aren't, you're not allowed to have that negative under the radical, then you just say not real. My opinion is that you don't need a calculator for any of these. Now, I know some of you just always want to use one, but I think you can do any of these problems without a calculator fairly simply. And I would challenge you to try to do that without a calculator first. All right, let's start with this first one, A. Do we have a problem with a negative? Is this an issue? Yes or no?
Yeah. No.
When is it an issue to have a negative under the radical?
Even a radicand.
No? Good attempt at using the vocabulary, though? Index. Okay, so when the index is even...
That's what I meant to say.
I know what you meant. Good job.
I thought that was... What's the radicand?
This is the radicand.
Oh.
This is the index. So when the index is even, we have to worry about it. If it's odd, it's not a big deal. Because let's think about it. Like, what is the answer to this? -5. Because -5 to the third power... This is why it's -5. That's -5 times -5 times -5, which of course does give me a negative. Okay. That's why it's okay to have a negative under there. So A is -5. How many of you had that right? All right, 4 of you. Great.
Oh.
How many of you thought you couldn't do it because it was negative? Okay, so let's be careful about that. Now B, those of you who are staring at B and thinking, oh, 144 over 121, I don't know what that is. What am I supposed to figure that out? Well, what's the easiest way to think about this?
Square root each one.
Exactly. Square root 144, the square root of 121, which is, so what is my answer? 12 over 11 is correct. Very good. All right, C. Now, I don't expect you to know the fifth root of 0.00001, but I would expect you to try something here, right? If I know I'm taking, like I'm looking for a number that I raise to the fifth power that equals that number. So the easiest place to start would be just to say, okay, is 0.1 to the fifth power, is that going to do it for me? And maybe that's where you grab your calculator and try to see if that works out. And in reality, it does. And so that's where you should have started, 0.1. Do we have an issue with D? We have a negative underneath. Is this okay or not? It is not okay because the index is even. Okay, this is just not real. Now, those of you who tried to use E or I in there, an imaginary number, the imaginary number is the square root of -1. So it only works, the i's only come into play when we have the square root of a negative. So just stick with not real for that one. And then E is fine. The negative's on the outside, so it doesn't even apply at all. So my final answer is going to be negative. What is the sixth root of 64?
2.
2. It is 2. So -2 is my answer. Anybody have all 5 of those right? Good. All right, moving on. Objectives 2 and 3 now, and I'm going to smush these together into one section basically. Now we're talking about rational exponents. This is all related because rational exponents is just another way of writing radicals. And what we're talking about here is powers that are fractions. Powers that are fractions. That's what rational exponents mean. Okay? And again, here's going to be another thing. This is on page 28 in your book, or you can take a picture. Go ahead and get that situated, and we'll talk through it. Here's what's going on in all this. Okay? This is all another way of writing radicals. And the book is consistent using n. Notice the n is the denominator in both of these examples. Okay, this n also still has to be greater than 1. The n is still the index. So when you have something to the fractional power, that denominator of that fraction is the index. Okay, the number on top, the numerator of that fractional power, is what you raise a to the power of. Now, most of the time, you're going to want to use this one. So, even over here where they didn't write it, you can think of this as all to the first power, which, of course, there's no reason to do that because it doesn't change anything. But you can think of this one as all that to the first power. Most of the time, you're going to want to use this version of it because taking the the nth root of a will make your numbers usually smaller, and then whatever that number is, you just raise to the mth power. Okay? That way you can work through it a little quickly. Here, if you take a to the mth power, then you're going to get some big number, and then you're going to take the nth power or the nth root of that. You're probably going to have a little tougher time doing that in your head. I default to this one, okay? Because then I can do it in my head and not worry about grabbing the calculator. Same situation. If n is even, because n is the index, then a has to be 0 or positive. If not, we're in a not real situation. Okay. All right. We have, let me look here. Just 5 more examples. Okay. No, I lied. I thought there was another whole set. Yeah. So there's 5 on this, and then we've got 3 more. 3 are tougher. These aren't so bad. Okay, so this, just in case you can't see it, 36 to the 1/2 power, 1 over 1/25 to the 1/3 power, -9 to the 1/2 power, -1 to the 4/3 power, and 16 to the 3/4 power. Yeah, give those a shot. What does this really mean? 36 to the 1/2 power? Square root of 36. That is correct, which is what? 6. Easy peasy. Okay. What is this really mean? 1 over 125 to the 1/3. Cube root of 125. Okay, this is what that really means. What is the cube root of 125? Yeah, so cube root of 1 is 1, cube root of 125 is 5, which is what you really do here, so that is 1/5. Any issues with C? Is that okay? Square root of -9?
No solution.
No.
No. Yeah.
You could say one of two things, right? You could say not real, or what else could you say? 3i, okay? So since it's the square root of a negative, we can use the imaginary numbers if we want. Okay, either one is fine. Eventually, you'll be required to say 3i, but we're pretending like we don't know the imaginary numbers yet. That will be later, yes. All right, so now D, here's where I think we ought to split up. This is the cube root of -1 to the 4th. And so like I said, what I like to do is do the radical first and then worry about the power on the outside. Because what is the cube root of -1? -1. Okay, cube root of -1 is -1. Okay, -1 to the 4th is 1. Okay? And then our last one. See, like I said, even though you could raise 16 to the 3rd power, you're going to get some big number that you're not going to know the 4th root of. That's why I suggest doing it this way, because what is the 4th root of 16? 2, right? So then that's 2 to the 3rd, which of course is 8. Okay? Anybody have all 5 of those right? Raise your hand if you had all 5 of those right, please. Okay, good. And now this is the last one. So there's 3 problems on this page. This is also on page 30 if you want to get it. But now we're going to start combining our power rules together with radicals, and they're going to get trickier. Okay, and then we're also going to deal with variables, because in the last problems they were all just straight up numbers. Now we want to look at ones with variables. We want to use our power rules, and then we want to kind of go from there. So these are going to be trickier. I'll give you a little more time for these. So in this first one, remember, a fraction bar is a grouping symbol. It forces the top to be grouped together, the bottom to be grouped together. So what I would do is combine these. When you multiply exponents that have the same base, what do you do with the powers? Add them. So what is 3/4 plus 10/4? Oh, did I just say 10/4? Yeah. Dang it. 3/4 plus 7/4 is 10/4. Okay. So now I've simplified the top as much as I can. Okay. So when I divide, what do I do with the powers? Same base. Subtract. So what is 10/4 minus 1/4? 9/4. Okay. And for now, that's good enough. We could simplify it a little bit, but we're not going to. We're just going to leave it like that. Simplified, rational exponent. Okay? All right. This one, there's a whole lot going on. Can I combine anything inside the parentheses? Can I add, subtract, do anything here? No, I can't. So I just have to raise everything to the 3rd power. Same with over here. I have to raise everything to the 2nd power. So when I raise something, a power to a power, what do I do with those powers? You multiply. So this is 4 to the 3rd. What is a to the 2/3 times 3? Okay. So actually, I'll just write it all out first. Let's just write it out so we understand exactly what's going on. And if you don't need to write it all out because you get what to do, that's okay. So basically, this is 4 to the 3rd, then a to the 2/3 times 3. So power to a power, we multiply. B to the 1/6 times 3. Same thing here. B to the 1/4 times 2. 3 squared. Don't forget about the numbers. One of the things that people tend to forget when we get into problems like this is raising the coefficients to that power. And we're not multiplying, you raise it to the power. All right? So now we just have to simplify. What is 4 to the 3rd? 64. 2/3 times 3. 2/3 times 3.
2.
It is 2. 1/6 times 3. 1/2. Okay. 1/4 times 2.
1/2.
3/4 times 2.
2.
3 over 2, and then 3 squared. 9. Okay, so here's where I'm at right now. This is what we've accomplished. Just simplifying. Multiplying the powers, raising the coefficients to the powers. And I've simplified as far as I can. Now I can keep going, right? Like, you can cancel tops with bottoms. You can subtract power over a power, or an exponent over an exponent. So, like, these are just going to straight up cancel out, right? B to the 1/2, B to the 1/2. Top and bottom cancel it out. What am I going to do here with this a to the second over a to the 3/2? What do you do when you divide? Subtract the power. So what is 2 minus 3/2? 1/2. Okay. Can I reduce anything between 64 and 9? Do they have any factors in common? Does 3 go into 64? Does 9 go into 64? No. So I can't do anything more with that. All right. And then, of course, we did that subtraction part. And there's my final answer. A to the 1/2. Okay? So these start getting a little trickier. Any questions on that? Did anybody have that one right? That's not good. Okay. Last one. Is there a problem with this? Can I have a negative here? Yes. What is the index here? 3. The index is 3. So we're fine. It's odd. All right. So here's my setup. Okay. First, I have to move it down because you can't have a negative power. So we move it down to get rid of that negative power. Now I can turn the radical. I can deal with the radical. Because as we also said, this number has to be positive. So in order to turn it positive, you have to move it down like we did in the last lessons where we were getting rid of negative powers. Now I can simplify. Okay, so this is the cube root of negative 125 squared. What is the cube root of negative 125? Negative 5, so that's negative 5 squared, which is? What's negative 5 squared? 25. Final answer.